Okay, so here's that problem that hopefully you tried on your own. So we're going to put this into point slope form because this does not equal 0, and so we know that this is not my y-intercept. So we're going to say y minus my y, which is negative 3, is equal to m, which is 1/2, times x minus whatever my x is, which is 1. And now I'm going to simplify. Always the same simplification process, distributive process first. So y plus 3, negative and a negative, right, equals 1/2 times x, which is 1/2 x, and then minus 1/2 times 1, which is 1/2. Now, I don't want to confuse you or anything here, but I need this in terms of halves to add it over here, don't I? So I'm going to put this over 1, right, and multiply this by a 2, and multiply this by a 2, and that's what I'm going to be adding the opposite of. So I'm going to add the opposite of 2 times 3, which is 6, over 2, 6/2, which is the same thing as 3, right? So I'm going to add the 6/2 in over here, and now I see that y is equal to 1/2 x, and then minus 1 plus 6, which is 7, and those are halves. And there we go. There's my slope-intercept form, which is what I want you to end with. All right, example number 20 here. You cannot use point-slope form, you can't use slope-intercept form on this because the slope is undefined. When the slope is undefined, we know that this is a vertical line, and vertical lines are not functions. And the point-slope form and the slope-intercept form are both functions. So point-slope and slope-intercept are functions. Let me write that in there really quickly. So point-slope and slope-intercept, they are functions. So those two are not going to meld well. So I can't use these. So that means, let's do this. Can't use those, and that kind of says it a little bit better. So I can't use those. And so remember that in order to get the equation, I have to recognize that this leads to a vertical line, which means that I have to go find out what the x is equal to, and then I can say that x is equal to that value. So x equals 0 is the equation for this vertical line, and that's the only way I can get it. Now moving on to example number 21. This example we have the second scenario. We're just given two ordered pairs. So the first thing that we always do when we see ordered pairs, we're going to look at the x's. Nope, not the same. Look at the y's. Nope, they're not the same. So it's not a vertical or a horizontal line. So the first thing when we're given a set of ordered pairs is we've got to find the slope. y2 minus y1. So 5 minus 2. Over x2 minus x1, 2 minus 5. Make sure you check those and see that denominator to numerator you see an ordered pair, 5 minus 2 is 3, 2 minus 5 is a negative 3, so my slope is a negative 1. Now, because neither of these, this one or this one, right, neither of those are 0, I know I don't have my y-intercept, so that's what leads me down the path of point-slope form. So y minus, now I can choose either one. I'm going to choose this ordered pair as my x1 at y1. You could choose this one. You're going to get the same thing as long as you do all the basic math right. So y minus 2 is equal to negative 1, my slope, times x minus my x1, which is 5. And then distributive property, because that's my next step. So y minus 2 is equal to negative 1 times x, which is negative x, plus a 5. And then one last step, I move the x or the constant over to the right, so add 2 to both sides, and y is equal to negative x plus 7. You should probably try it with the ordered pair, the other ordered pair, and show that you get the same exact thing. I won't do it here, but you probably should. Now, if we ever are in question, remember you can check these by seeing if they satisfy.